In calculus, we're still working on taking derivatives. We're going to mix it up a little bit today and take the derivative of the letter x and of the letter y. And when you do that, take the derivative of x and y, that's called implicit differentiation. So implicit differentiation is taking the derivative of the letter y, which we haven't done. And when you do implicit today, we're going to distinguish between functions written in implicit form and explicit form, and use implicit differentiation to find the derivatives of some functions. So this is the explicit form. It's not solve for y. The explicit form is when we take this equation and we solve it for the letter y. So get rid of the x, divide by x. This is the explicit form. So implicit is not solve for y, not solve for y. Explicit is solve for y. And then once it's solved for y, this one right here, 1 over x, float it up, make it a negative, and then you can take the derivative of it pretty quickly. All right, so the guidelines for doing implicit differentiation is you differentiate both sides of it with respect to x, collect all the terms involving dy over dx on the left side, and move all the other terms to the right side. So just pick a side, move them all to one side, all the ones with the y prime or the dy over dx, and move everything else to the other side. Then you factor out dy over dx to the left side and then solve for it. So again, dy over dx, I like to just do y prime. It goes quicker that way instead of writing all that over and over again. But I think I'll do the first one here with that dy over dx for you to think about it. So the first one here, number 6, says, solve by implicit differentiation, x squared minus y squared equals 25. So we know how the derivative of x squared, it's 2x. And we took the derivative of the letter x just now with respect to x. We're taking the derivative of x all the way across. We usually don't bother writing the derivative of x with respect to x because it's kind of repetitive and it just cancels out. It's like it's not there. But since we're doing implicit differentiation, I just want to write it out for you. So then the derivative of y squared is 2y. So we took the derivative of y, and again, we're doing it with respect to x. And then the derivative of 25 is still just 0. And so cleaning it up here, this chunk here, so we have two chunks. We have this one and we have this one. This is the one with the y prime, or the dy over dx. So I'm going to leave that on the left, is what the directions say to do. Move the one without that to the right, when that's the 2x, so it becomes negative 2x. So solving for dy over dx then, I'm going to move that over here and divide by the negative 2y. So you end up with just x over y because the 2's cancel out. So the derivative of y with respect to x is x over y. So let me show you another way to do it. Instead of writing dy over dx every time, it's nice to just write y prime. So doing it again here. X squared minus y squared equals 25. The derivative of x squared is 2x. The derivative of y squared is 2y, y prime. And the derivative of 25 is 0. So whenever you take the derivative of the letter y, you're going to need to write y prime. And again, we've got two chunks, and so leave this chunk on the left. I'm going to move the other chunk to the right, which makes it negative 2x. Solve for the y prime, so get rid of the negative 2y because it's multiplied. Both of them are multiplied by the y prime. So y prime is negative 2x over negative 2y, which is just x over y. All right, let's do some more complicated ones here. All right, on number 10, we have x squared y times y squared x equal to negative 2. Got to be careful here. We've actually got the product rule going because it's x squared times y and y squared times x. So we're going to have to do the product rule on this one twice on number 10. So doing the product rule on it, we're going to do this chunk first. Take the derivative of the first term, so that would be 2x, times the second, which is y, and then plus the derivative of the second term, which is y. The derivative of y is just 1, but we took the derivative of y, so I have to write prime. So y prime. And then times the first one, x squared. And then plus, now doing the second one, I'm going to take the derivative of the first one. The derivative of y squared is 2y, y prime. Whenever you do the derivative of the letter y, you're going to write y prime. And then times the second term, x, plus then the derivative of the second term, which is just 1. The derivative of x is 1, times the first term, y squared. And then the derivative of negative 2, gone, it's 0. All right, so we've got 4 pieces over there. We got this one's got a y prime, this one's got a y prime, the other 2 do not. So I'm just going to move those to the other side. So that gives us y prime x squared plus 2y y prime x equals, moving those 2 chunks to the other side, that gives you negative 2xy minus y squared. And then so the directions said get all the y primes on one side and then factor out the y prime. So I'm going to factor out the y prime from this. So y prime then would be times x squared plus 2xy equals then negative 2xy minus y squared. So now that it's solved for the y prime, I'm just going to get rid of this whole chunk. It's y prime times this whole chunk. So just divide by it. So y prime is equal to negative 2xy minus y squared divided by x squared plus 2xy. That's the whole answer on it. All right. Go on to the next page. Do some one with sines and cosine in it. So number 16, we want the derivative of sine pi x plus cosine pi y to the second equal to 2. I would use the product rule on it. I wouldn't FOIL that much out. Just use the product. Well, not the product rule. I want to say the chain rule. So let's use the chain rule. So we've got a big chunk here to the power of 2. So pull the 2 out front. So that would make it 2 times the sine of pi x plus cosine pi y, and then to the first. So I did the derivative of this chunk here. Pull the 2 out, take 1 less than it, and it's just times the inside. But then we're going to need to do the derivative of that chunk there. So the derivative of that chunk, I put a bracket, you can use parentheses. The derivative of sine is cosine pi x. And again, we don't have a rule for the derivative of the sine of pi x. Our rule is for the derivative of sine of just the letter x, just an x, not pi x. So that's something that we have to take the derivative of also. So take the derivative of that, and it's pi. And then doing the second one here, plus the derivative of cosine is negative sine pi y. And then do the derivative of the pi y, and the derivative of that is pi y prime. So the derivative of pi x was just pi, because that's like a constant. So, all right, the letter pi freaks people out. If we had, we're going to suppose land now, if we had y is equal to 3x, y prime would be just the number 3. If you took the derivative of it, it's just 3. So here we have y equals pi x, so the derivative of that is just pi. Again, pi is just a number like the number 3. Don't let it freak you out. Remain calm. So sine pi y, and then the derivative of pi y is pi, but we took the derivative of y, so I have to write y prime. And then the derivative of 2 is just 0. All right, so we have this chunk times that chunk times the number 2, and it's all equal to 0. Why don't we just go ahead and divide by that chunk right now, so it's gone. And we'll divide by the 2. It's gone because we divided it by 0. 0 divided by that, 0, so it's gone. So that leaves then pi cosine pi x minus pi y prime of sine pi y equals 0. All right, so it's pretty much solved. We need to solve it for y prime now. And that's just chunk right here. So I'm going to move this piece to the other side. So it's minus pi sine pi y prime. I move the y prime to the back there for fun. And so that equals then negative pi cosine pi x. Notice both sides have a pi. Let's just get rid of it and just be done with it. Didn't mean to cross it off there. All right, so then y prime is equal to this, the cosine of pi x, divided by negative sine pi y. That's it. That's the answer to the whole thing. All right. I think we have time to do some other problems here involving implicit differentiation. All right, so we're going to the next one here. Find the slope of the graph. Find dy dx by implicit differentiation, then find the slope of the graph at the given point. It says 4y to the third is equal to x squared minus 36 over x to the third plus 36 at the point 6, 0. That's a 0. All right, so we're going to have to do implicit differentiation. Remember, define the slope. You differentiate and then you plug in the number x in. But when you do it for implicit differentiation, you're going to have to plug the x and the y in. So that's kind of what's different. When you do implicit differentiation and you find the slope, you have to plug in x and y. So that's what's different on it. All right, let's go for it here. On the left, we've got 4y to the third. So that would be 12y to the second y prime. And then on the right, we've got a quotient. So I'm going to do the derivative of the top, which is 2x, times the denominator, which is x to the third plus 36, minus the derivative of the denominator, which would be 3x squared, and then times the top, and then all over the denominator squared. Let me stare at it for a second here, see if I did anything wrong. All right, I think it's good. All right, so eyeballing it here, you've got on the left these three pieces, or these three kind of chunks inside there, separated on the top by the minus sign. We have this piece and this piece. All the pieces have an x squared plus 36 in them. So to all three of the pieces, you can divide or factor out and then cancel out the x squared plus. Oh, no, I can't, because the one's plus, the other one's minus. Oh, that's a sad story. We can't do that. All right, so what I'm going to do is go ahead and, you know what? I don't really care. At this point, what you can do, honestly, we need to solve for y prime, and it's right here. So all I need to do is get rid of that. So I'm going to divide by it. So it's divided by 12y squared. And then the whole goal of the problem was to find the slope at the point 6, 0. I'm just going to plug it in and be done with it. So 0, oh, that'll make it beautiful too, because when we plug in the 0, that might help us. I don't know. So x is 6, so that'd be 2 times 6. Then parentheses 6 to the third plus 36 minus 3 times x squared again, which is 6. And then times 6 squared minus 36 over then, when we divide by that, then we're going to get, because y is 0, it's going to multiply by 0. So it does make it really fast. Oh my heavens. That does go fast. I do remember. So that is 12 times 0 squared. So there's 0 in the denominator that you're multiplying by. So the whole answer is just undefined. So the slope for the whole thing is undefined. That was kind of fun. All that work, and thank heavens I didn't bother cleaning that mess up to learn that it was undefined. All right, done with that. And I checked it, by the way. We were right. I don't know. Do we need to do more? Let me think how much time we got left. We got a lot of time left. All right, we could do another one. Well, let's do 30. On 30, it's on the last one we plugged in that point, 2, 3. So again, we're trying to find the slope at the point 2, 3. So again, we got to do different implicit differentiation on it. It's x to the third plus y to the third equals 6xy minus 1 at the point 2, 3. All right, so let's implicit differentiate it. So the derivative of x to the third, 3x squared. The derivative of y to the third is 3y squared, y prime. And then you got a little bit of a product rule going here. So we're going to have to do that. I'll do that in red for fun. So the derivative of 6x is 6 times the second term y, and then plus the derivative of the second one would be y prime times the first, which was 6x. And then the derivative of minus 1, gone. All right, so we're going to have to clean it up a little bit because we have a y prime in two different places. So we have 1, 2, 3, 4 chunks here. This chunk's got to go to the left. This chunk's going to go to the right. So that'd give us 3y squared y prime minus 6x y prime equals then 3x squared plus 6y. Oh, and it'd be negative. I moved the 3x squared to the other side, so now it's negative. So factor out the y prime. And then last step is you're going to divide by this chunk. So y prime is negative 3x squared plus 6y over 3y squared minus 6x. All right, the moment of fate here. We want to find the slope then at the point, yeah, we did it right, at the point 2, 3. So I'm going to plug 2, 3 in here now. So that would make it negative 3 times 2 squared plus 6 times 3 over 3 times 3 squared minus 6 times 2. And if you did the math on all that, you're going to get 2/5. All right, that's enough. I'll see you for the next lesson.